It's important at this point to recall the bullwhip effect, which we looked at earlier on in the semester, which is the tendency of supply chains to amplify relatively small changes at the demand side of a supply chain, such that the disruption at the supply end of the chain is much greater. Simply means if there is, given that we've got a perfect supply chain or a very tight supply chain run on a just-in-time basis, if demand changes, i.e. we get more people consuming the product or less, then it actually reverberates back up the supply chain, and the further up it goes, the greater the effect. That's because a distribution centre that has planned for, let's say, 10,000 garments moving through it in the month of January, all of a sudden has over or under capacity, and then that will affect the manufacturer and the end supplier. So some of the causes of a bullwhip effect are non-zero lead time, so a tight supply chain or a just-in-time system. Order batching, when the whole chain is set up around delivering a certain quantity of garments through the chain at one time. Demand variation I spoke of before. Price variation, which in turn impacts on demand. And communication or lack of communication within the supply chain is also going to create this bullwhip effect. So the advantage of having an efficient supply chain is that you may, as a consequence of altering demand, end up with inefficiencies within that chain. Moving on to MRP systems, this is one of the computerized systems, well, it can be paper-based systems, material requirements planning, which simply put takes into account the expected number of garments we're going to sell over a given period, the orders that we currently have for that period, and it feeds that into the system along with what's in the inventory at the moment, and a bills of material being the requisite components of perhaps making a garment up, and that all gets churned out and produces a works order, materials plan and purchase orders. So based on forecast demand of what we want to create, what we currently have, it will tell us how much we should produce, when we should produce it. And this is, if you like, a materials requirement plan. So it becomes like the central information center to determine what's moving in which direction. That then continues on into this new phenomenon which has sort of been occurring for the last 20 years or so. Automation and computerization of the process means you need less human beings. And so because computers are doing more of the job, or at least they're telling us how much we should produce or move at any one time, then that's excuse me, that's going to affect the type of jobs we have in the supply chain. And it also affects this other balance or equilibrium between the social systems and technological systems. Simply put, human beings are still important in the process. We sometimes exclude them from the process because we deem them to be inefficient. So if we have a look at this table for a moment, so we've got two systems sitting side by side here, the social system and the technological system. On the social side, it's made up of two components. One are the people, that's you and I, or if you have a look in the mirror you'll see one. And the other component is the structure. So that's people in the workplace, people interacting with other people in different workplaces, if you like. Structures may involve the hours that we work, the type of jobs that we do, etc. On the technological side, we have tasks that need to be achieved. It may be the delivery of a product, a garment, to a specific place, or the unpacking of a garment, or the labeling of a garment, and then the technology used to successfully complete that task. And what this systems theory intends to display is that they're all interconnected, so you can't allow one component to override the other ones. Technology is important, computer systems are important, but ultimately you need people who are able to monitor those computer systems and make judgment calls which are perhaps beyond the capacity of a computer system. Equally, on the structural side, you may have structures, a hierarchy within the organisation where the boss has got a clear set of what they do and what they leave to their subordinates, and that needs to be continually reviewed. So who does what and in the task. The overall idea behind this theory is that as much as computer systems are getting better and better at predicting what we want and telling us indeed what we should do next, we still can't exclude people and the way they interrelate with each other. Okay, the final slide, which I'll do in the next video, excuse me, is just a brief revision of what we're doing.